continuation of the last previous module. There I explained to you two methods to find derivative in case of parametric function. If you look at this function, you notice that x is a function of t, y is a function of t, but you want the answer in x and y, which means we need to remove t and form an equation with x and y. There are different methods to do that. So you may find it a little difficult in this part of how to eliminate t. Depending on the function, we use different techniques. For example, whenever you have trigonometric functions, we use this three formula. Sin square theta plus cos square theta is 1. Second formula, sec square theta minus tan square theta is 1. And third formula, cosec square theta minus cot square theta is 1. These are the usual formulae that we apply to eliminate the parameter. Then if there is an inverse function, we can apply sin inverse x plus cos inverse x is pi by 2. Like this, tan inverse x plus cot inverse x is pi by 2. So inverse function, we may apply this formula to eliminate. Second method is make t as a subject and substitute in y. So using, let's say, x is function, x is f of t, y is g of t. From here, make t as a subject and substitute in this. So t will be eliminated. Then you differentiate, you can get the answer. So here, there's trigonometry involved, sec tan t and sec t. So I will use this formula to eliminate t. So taking log x, I get log x equal to tan t. Taking here log y is equal to sec t. And we know that sec square t minus tan square t is 1. So I take sec square t minus tan square t is equal to 1. So instead of sec square t, I'll write log y the whole square minus log x the whole square equal to 1. Now if I differentiate this with respect to x, I'll directly come to this answer. So differentiating with respect to x. So dy dx of log y the whole square minus dy dx of log x the whole square equal to dy dx of 1. So I can get 2 log y into derivative of log y. I'm differentiating with respect to x minus 2 log x into derivative of log x equal to 0. So now I can write 2 log y into 1 by y dy by dx minus 2 log x into 1 by x equal to 0. From this, I need to find dy by dx as a subject. So I can write dy by dx is equal to 2 log x into 1 by x divided by the coefficient of dy by dx, 2 log y into 1 by y. 2 will get cancelled. So y log x is equal to x log y becomes my final answer. So you can see y log x upon x log y is dy by dx. So the most important thing to remember is whenever trigonometric ratios are there, these are the formulae that you can use for eliminating t, eliminating the parameter. After eliminating the parameter, differentiate with respect to x, you will come to the answer. And when will you do this method? When the answer does not contain the parameter. The answer does not contain the parameter. Previous module, what we did, the answer contains parameter. Now dy by dx does not contain parameter. So method that we adopt is eliminate the parameter by using, if trigonometry uses ideas, if some other function use some other idea, eliminate the parameter, make an equation only in x and y, differentiate with respect to x, you will get the answer. Problem, we see cosec theta and cot theta, cosec theta plus cot theta, and our aim is to eliminate theta and come to answer containing both y and x. So this is also important, getting both y and x. So how can we use the formula? We know the formula for cosec theta. So cosec square theta minus cot square theta is 1. This is a formula we should need to apply. And if you notice, if you multiply both of them, you can come to this. So you will multiply x into y is a into root of a into a. I can write a square. And directly cosec theta minus cot theta into cosec theta plus cot theta. So what happens now? xy is equal to a square into root of cosec square theta minus cot square theta. So xy is equal to a square into 1. Now there are two ways. Suppose I make y as a subject, my answer will contain a square in it. Now you notice that the answer does not contain a square. So you need to keep a square alone on one side and differentiate, so that when you differentiate, a square will go away. So differentiating with respect to x. So d by dx of xy is equal to d by dx of a square. So the a square goes away. X into derivative of y plus y into derivative of x is equal to 0. And from here I get dy by dx is equal to, this y goes to left, so minus y. The coefficient of dy by dx is divided, so hence I get the answer as minus y by x. So every time you need to use the technique which way we can eliminate theta, and accordingly we change. In this problem we have cos and sine. Whenever we have cos and sine, our A will be use cos square theta plus sine square theta is 1 to eliminate t. So we have answer in y and x. So we don't want t to be present in the answer. So our aim is to eliminate the t. So what I do is I make cos t as a subject. So I can write cos cube t is x upon a, and cos t is x upon a raised to 1 by 3. Same way, I can write y sine cube t as y by a and sine t as y by a raised to 1 by 3. Now what I'll do? In place of cos, so we know cos square t plus sine square t is 1. So in place of cos, I'll write x by a raised to 1 by 3 the whole square plus y by a raised to 1 by 3 the whole square equal to 1. This can be further simplified as x raised to 2 by 3 plus y raised to 2 by 3, and the LCM is a raised to 2 by 3, which gets cross multiplied. Why did I cross multiply this? Is because my answer does not contain a, so I need to keep a on the right hand side as a single term. I should not carry on any other term with it. Now if you differentiate, naturally a raised to 2 by 3's derivative will become 0, and answer will not contain that. So I will differentiate with respect to x. So d by dx of x raised to 2 by 3 plus d by dx of y raised to 2 by 3 is equal to d by dx of a raised to 2 by 3. Because you are differentiating with respect to x, a is a constant, so derivative of a will be 0. So 2 by 3 x raised to minus 1 by 3, derivative of x raised to 2 by 3 is n into x raised to n minus 1, 2 by 3 minus 1 is minus 1 by 3. Same way, 2 by 3 y raised to minus 1 by 3 into dy by dx equal to 0. You are differentiating y with respect to x, so dy by dx has come. So from this, dy by dx is equal to, this goes to the other side, minus 2 by 3 x raised to minus 1 by 3 divided by 2 by 3 y raised to minus 1 by 3. 2 by 3 will get cancelled, minus x upon raised to minus 1 by 3. But I want the answer to be positive, power to be positive. So minus y by x raised to 1 by 3. You know that negative sign can be made positive by taking the reciprocal. So which can be written as minus cube root of y by x. So cube root of y by x. That's what is your answer. Problem, there is no trigonometric functions as such. But we know that if t is replaced by tan theta, this will become sin 2 theta's formula. And if you replace t by tan theta, this will become cos 2 theta's formula. So we can bring trigonometric ratio in it, although it is directly trigonometric ratios are not present in it. So what is my technique is, put t as tan theta in both of this term. So x will be 2b into 2 tan theta upon 1 plus tan square theta. So x will be b sin 2 theta. As usual, I'll make sin 2 theta as subject. So sin 2 theta is x upon b. Same procedure I'll do with y. Y is a into 1 minus tan square theta upon 1 plus tan square theta. So y is equal to a into cos 2 theta. So cos 2 theta is y by a. Now to eliminate theta, as you know what to do, sin square 2 theta plus cos square 2 theta is 1. So replace it. X by b the whole square plus y by a the whole square is 1. Now for the purpose of differentiation, 1 by b square into x square plus 1 by a square into y square is equal to 1. Now what I can do about this, differentiate with respect to x, because I need this answer. So differentiating with respect to x, 1 by b square into derivative of x square plus 1 by a square into derivative of y square is derivative of 1, which is 0. Derivative of 1 is 0. So 1 by b square into 2x, 1 by a square into 2y divided by dx will be 0. So now 1 by a square 2y divided by dx is minus 1 by b square into 2x. The 2's will get cancelled. So dy by dx will be minus a square x upon b square y. And that gives me my answer. So in this problem, although trigonometric ratio was not present, we could convert them into trigonometric ratios and then eliminate theta. We are supposed to eliminate t, but what we did here, we eliminated theta and we brought an equation only x and y, and on differentiating that you get the answer. The method to eliminate using inverse trigonometric function. You can see x equal to a raised to sine inverse t, y is equal to a raised to cos inverse t. So what can I do this? I will make sine inverse t and cos inverse t as a subject. So first I can write x square is equal to a raised to sine inverse t. And I can write here y square equal to a raised to cos inverse t. And what formula I want to apply to eliminate? Sine inverse t plus cos inverse t is pi by 2. How can I get sine inverse t plus cos inverse t? If you multiply both of them, x square into y square is a raised to sine inverse t into a raised to cos inverse t. We know that a raised to m into a raised to n is a raised to m plus n. So I can write x square into y square a raised to sine inverse t plus cos inverse t. And x square plus y square is a raised to pi by 2. Now I have eliminated t from the equation. Now if I differentiate, I'll get this answer. So let me differentiate with respect to x. So differentiating with respect to x, d by dx of x square y square is d by dx of a raised to pi by 2. Now you know that a raised to pi by 2 is a constant, so its derivative is 0. So I can write now this as x square into d by dx of y square plus y square into d by dx of x square is d by dx of a raised to pi by 2, which will be 0. And if I continue this, what will be my answer? X square into 2y divided by dx plus y square into 2x will be 0. So x square into 2y divided by dx is minus y square 2x. 2 will get cancelled. So dy by dx will be, y will get cancelled. So minus y upon x. That will be my answer. So this is how you can do it in few steps. To eliminate t in a very special way, there's not trigonometric function here. We use algebraic formula to eliminate x square, y square, x raised to 4, y raised to 4. And the answer should be in this. There's no t in it. So first you have to eliminate t. You notice that they are reciprocal of each other. So if I use the formula a plus b the whole square is a square plus b square plus 2ab, I can eliminate it. Instead of a, I put e raised to t and e raised to minus t the whole square. Is e raised to t the whole square, so e raised to 2t, e raised to minus 2t, and 2 into e raised to t into e raised to minus t. Now this can be replaced by x square plus y square, and this can be replaced by x raised to 4 plus y raised to 4, and they both will get cancelled, so you will get answers 2. That is e raised to t into 1 upon e raised to t, they get cancelled. Now you can further simplify this by expanding it. So x raised to 4 plus 2x square y square plus y raised to 4 is x raised to 4 plus y raised to 4 plus 2. Again, there's a cancellation here. So when you cancel this both will get cancelled. Even 2 and 2 will get cancelled. So you end up in x square y square equal to 1. Now you can differentiate this in many ways, but you need an x cube here and y square. So what I'll do is I'll write y square equal to 1 by x square. So that when you differentiate this, I will get x cube. So now I differentiate this. Differentiate with respect to x. So d by dx of y square is equal to d by dx of x raised to minus 2. When you differentiate this, 2y divided by dx is equal to minus 2 x raised to minus 3. Again, 2 will get cancelled. So you will get the answer as y dy by dx is equal to minus 1 upon x cube. So what is dy by dx? So then you cross multiply, we want this answer. So we have a negative sign here. So x cube dy by dx will give you minus 1. So your answer should have been minus 1. So there's no other place we have. So there'll be a minus sign here. So your answer should be x cube y dy by dx. X cube y dy by dx is equal to. This problem more works on observation, because one method I can think in my mind is to eliminate t. I can write e raised to x equal to 1 plus t square. Then I can make t as a subject. Then wherever t is there, replace it, then differentiate. You can eliminate t this way. But you notice another important thing. When I find the derivative of this and when I find the derivative of this, there is a similarity. So I'm going to use that into doing this problem. So first I'll differentiate. After differentiating, I'll think of removing t. So in my derivative, first t will be present. After that, I'll remove the t. So first dx by dt is 1 upon 1 plus t square into derivative of t square, that is 2t. Now I'll differentiate y, dy by dt. 1 minus 1 upon 1 plus t square. If I take the LCM, 1 plus t square minus 1 upon 1 plus t square, which I get t square upon 1 plus t square. Now I need to find dy by dx, which is dy by dt divided by dx by dt. So I have used which method? I used the method that we did in the previous module. So dy by dt is t square upon 1 plus t square, and dx by dt is 2t upon 1 plus t square. So what I can do here, t square will get cancelled and I'll get t by 2. So my answer for dy by dx is t by 2. Now it is very easy. I want the answer in terms of x. So from here, I can find out what is t. Make t as subject from here. I won't use this because I want the answer to be in x. So this is my equation 1. Now I will take the function x. X equal to log of 1 plus t square. So e raised to x is 1 plus t square, which implies t square is e raised to x minus 1. So what is t? Root of e raised to x minus 1. So I can substitute now here. This is my equation number 2. So substituting dy by dx is t by 2, and t is replaced by root of e raised to x minus 1 upon 2. How did I get this? Substituting t as e raised to x minus root of e raised to x minus 1. So what is the method I have adopted in this? I saw that when I find dy by dx by parametric method, it changes to a very small term t, because 1 plus t square and 1 plus t square are present here, both in the denominator when you find the derivative. So eliminating that 1 plus t square would not be a difficult task. And after you got the answer, I found out t using the function, what is given to me. I made t as a subject and substitute t back here to get my answer in the format. So every time you need to think how to go about the function. Majority of trigonometry function you can eliminate directly and find the derivative. Only in this very special case, what we do is find the derivative and eliminate t. So that is not always done. It's only in a special